Is there anything that I can help you with? So we're here for our second virtual class, and you are the only person that shows up so far. So hopefully that means that you're gonna get an A.
I know. I was talking to the other classmates. I think they're coming because I was texting them through the email, so I think they are gonna show up.
Oh, okay, cool.
Yeah.
Well, you should tell them that it starts at 1.
Okay.
And if any of them know me, for example, Tamia knows me. Have you been talking to Tamia?
Yeah, I've talked to her.
Yeah.
But only about the classwork.
Okay, yeah, because Tamia knows me, and she knows that I don't like people that are late.
Oh.
But anyway, what's up? Tell me, how can I help you?
I had a few questions. One was about the pre and post assessments. I know that we're able to take them like multiple times, but it doesn't let us know our what we score on it. So I wouldn't know like if should I take it over again because I don't know what I got.
I see what you're saying. I didn't know that. So I'm so sorry about that.
No, it's okay.
I thought I had set it so that you could see your answers, but maybe I did it after the due date. Okay, yes. So I will check that and change all of them from now on.
Okay, thank you.
Change pre-assessments to see answers. Got it.
And then I was getting stuck on because I would feel like I get it, like the conversion ones when you had to convert from different, convert from, what is it? Like a different, so let's just say grams to miles or something. Like
well,
I would
to miles doesn't work.
Oh yeah, because it's different. It's a different metric unit, but like
to length does not work. But so you mean like metric units from like
metric units.
So like picometer to kilometer.
Yeah, because I would think I would get it, and then when I get the word problems, just like sometimes the word problems are confusing. I'm like, I'm stuck. And then when I see the right answer, I'm like, oh, okay, I get it. And then when I get another question, I'm like, I'm stuck again.
Okay, so then that means that if you understand the answer after you look at the how it's done, then that means you understand it. You're just not following the right protocol every time you do the problem, right? So you've got to figure out where you go wrong. Like, what is it that confuses you? So for example, first of all, to do metric unit conversions, you have to be really good at knowing the powers. That is the key, okay? I can teach you my way of converting because, I was a student once and I also had problems remembering stuff. And I had the main issue when I first started learning metric units was, okay, yeah, how do I know where to put the power? Like, I had really a big problem when I was comparing a meter to a centi. Do I put the 10 to the third here? Do I put the 10 to the third over here? Do I put the 10 to the second? So that was my problem. I always would get it wrong. So I figured out a way to do it. But anyway, before you even figure that out, you've got to know your powers. And by that, I mean, you have to memorize the power and the name. And yeah, that's it. Basically the power, the name. So pico, I know that it's 10 to the negative 12. You have to know that like to the second, because you can't spend time thinking about that. So in the video, I sort of give this stupid little song.
Yeah.
Right. So don't use my song because that song doesn't work for you. That song works for me. Make up a rhyme, make up something that works for you that you remember. But you do have to know attos, right? To like freaking kilo, what's the big ones? Mega, giga. Yes, you got to know all of them and know them like the back of your hand. So what I'm going to do is I'm going to write on my screen for a second, and I'm going to just do one quick example. And then I'm going to ask you if you understand it. And then if you do, then we're going to do another one, and you're going to tell me what to do.
Okay.
Cool. All right. So let me share my screen. What do I want to share? Let's share the whole thing, but I hope I don't show you anything that is confidential. Oh, well, that's just my email. That doesn't matter. Okay. You can see my screen, right?
Yes.
Very cool. So I am going to, let's close this out. There we go. All right. Let me think. What do I want to do? Well, let me put my thing down. Sorry, you're not going to see me.
Okay.
But I'm here. So I have to. Okay, so what about, I don't know. Let's do something. Let's do something easy first. Let's do, how about, oh, that's not the pen I want. That's a nice looking pen, but I don't want that pen. Let's do that one. Let's do, yeah, let's do a simple one. How about meters to like micrometers? Okay.
Right.
And it doesn't matter the number, right? The number doesn't matter. Well, all I'm doing, it could be 100 or it could be 7,642. Doesn't matter. It's the setup that matters. So I want to go from meters to micrometers. I'm going to have meters here. So let's just say it's 1 so we can have a number. So 1 meter. And then to actually get rid of meters, you know, dimensional analysis, you have to put the thing that you want on the bottom,
Right.
and the thing that you want on the top, so that this can cancel. So I want to go from meters to micrometers, and I can do that relationship. One of the biggest problems that students have is that they just, I'll give them like 2 conversions, right? Like I'll be like, okay, go from meters to micrometers. Or for example, like your example, what you gave me, go from miles to grams, and they literally set it up as a 1-step process. Well, I mean, miles to grams doesn't make sense, but let's say it was something from like miles to centimeter cubed. That can't happen in 1 step, because remember, you have to do these on your own. You can't use Google to do them, because yes, you could go to Google and ask it in 1 step and it'll give you the answer, but that's not what you want, right? You want to be able to set it up on your own. So, but this, you can set it up in a 1-step process. Why? Because the home base, which is the person here, doesn't have, you know, it's the guy that relates every other metric unit, right? So there's a meter in every one of these metric units. There's a micrometer, there's a centimeter, there's a whatever meter, decimeter, everybody has a meter. So it's home base. So since it's home base, you can relate in 1 step from the home base to whatever unit you want. You understand what I mean?
Right. Yeah.
Okay, cool. So do you know what a micro is?
1,000.
That is incorrect.
1,000.
That is incorrect. So there, I can tell right there, that is your problem. You need to know the powers, that you need to know them. And what I'd suggest, Cecilia, is that you learn them as powers of 10, right? Okay. Not as numbers, because in chemistry, we deal with really, really small things, right? Like we don't deal with macro things. So things are not going to typically be 1,000. They're going to be like 10 to the negative 6 or 10 to the 9th. Really big things or really small things, usually really small things, because we're dealing with atoms and stuff like that. So I would suggest, go to the book, and there is a chart, there's a table that shows all the powers and all their names and all the decimals, blah, blah, blah. All you got to do, like in the video, I state, know the name and know what power it corresponds to. So for example, a micrometer is 10 to the negative 6. Okay, so you need 10 to the negative 6, and I'm going to just go off on a tangent here, but try to stay with me. 10 to the negative 6 is 1,000,000 times smaller than 1 meter. Okay, so not 1,000. You had said 1,000. And micro is less than 1, right? So micro, the power of 10 is 10 to the negative 6. The meter is just 10 to the 1, 10 to the 0, sorry, which is equal to 1. Okay, so these are the 2 powers that you have to deal with. I guess let's make pretend that you did know it was 10 to the negative 6. Now the next question is, where do you put 10 to the negative? Because you have to show, when you draw a fraction, you're basically stating a relationship between those 2 units. You know what I mean?
Right.
Like how many times, how do these two things that are in the denominator and in the numerator, how do they relate to each other? So they relate to each other by this, by a million different steps. So the next question is, where do I put this relationship? Where do I put 10 to the negative 6? On the top or on the bottom?
Top.
And that's what I would say as a student, right? And that is wrong.
Oh.
Well, and I'll tell you why. And this is why I'm going to teach you how I always do it. And then I've recently started teaching it another way. But anyway, that's the exact same thing I would have, so you could see me. That is the exact same thing that I used to do as a student. Why? Because I know why you do it. It's because, okay, the teacher just told me a micro is 10 to the negative 6. So I'm going to put 10 to the negative 6 right next to the micro because that's what it is.
Right.
That makes sense. But remember, I'm not asking you simply what a micro is. I'm asking you to make the relationship between a micro and a meter. It's different. Now you're doing the relationship. So since you are saying that micro is negative 6 times smaller, right, than a meter, because it's 10 to the negative 6, you need a positive number of the small guys to get to one big guy. Does that make sense?
Wait, a positive number of.
Right, so this is 0.0001, 2, 3, 4, 5, 6. That's what a micro is, right?
Right.
So this is really, really less than 1. This is 1. This is really, really less than 1. Right? So you need a million of these, right? A positive number to get to one of these.
Right.
Does that make sense?
Yeah.
Are you sure? Say it over again and again in your.
Yeah, it does. Yeah.
Okay.
Yeah.
So the trick is when you're doing a relationship between two metric units, is figure out, first of all, you got to know them. You got to memorize them, the powers. And then once you know them, you have your relationship and you ask yourself, which one is the smallest one? Which one is the smallest one here between micro and meter? It's going to be micro because it's 10 to the negative 6 versus 1. So I'm going to need a positive number, whatever the definition is of micro, but I'm going to need a positive number of those to get to one big one. So I would put 10 to the what just happened? Oh my gosh. Oh my goodness, why did it get so big? Okay. 10 to the negative 6. I'm sorry, my bad. I'm gonna need a positive number, 10 to the 6 small guys to get to one big guy.
Okay.
Okay?
Oh, so you like flip them?
Yeah, you change the sign. You don't flip.
Okay.
You change the sign because you are stating it like you're in your brain. You're stating it from the smaller dude, which is always easy. It's easier because students tend to work better with positive exponents than negative exponents for whatever reason. That is one way of doing it. Okay. That's the fastest way of doing it. And we can do another problem just so you can kind of get a hang of it. But I'm going to show you in a little bit, I'm going to show you another way of doing it, which this is the way that I originally had taught it. But let's do one more trial. So let's go now from what powers do you know for sure? So that way, this could work.
I honestly don't memorize any of them. I just look at.
Okay, well then that's a problem. Yeah. You hear me?
Yeah.
Hear me? Like, do you hear me? For real, that is a problem. You're not gonna pass. I don't like memorization because I do give you the equation sheet and like the constant sheet, like I had told you. But you need to know the powers. You need to be able to convert between metric units, and this is going to be the major portion of your exam 1. So you need to know the powers. So memorize them. Stop complaining. Stop making excuses. Know them. You need to know that micro is 10 to the negative 6. You need to know that nano is 10 to the negative 9. And if you notice, they kind of go by 3s, right? So if you just know the names, you got to know them. So I'm going to go now from a nanometer to a kilometer. Okay. Nanometer is 10 to the well, let's do another easy one before we do something like that.
Isn't kilometer 10 to the 6?
No.
Oh.
Sure, that's big trouble, Cecilia, if you can't do this. You got it.
No, actually, it's 10 to the third. It's 10 to the third.
It is 10 to the third, correct.
Okay.
Let's do something easy again. So by easy, I mean home base to that number. So let's do, again, let's do meter to now let's do a nanometer, okay? So meter is 1. Nano, do you know what nano is?
Is to the, nano is to the 6.
No, this was, remember, okay, when you say to the 6, do you mean positive 6 or negative 6?
To the positive 6.
No, nano. Didn't you not get an iPod? Didn't you used to have a nano?
Oh, so small, yeah.
Yeah, nano is small. So it's 10 to the negative 9th. That's what a nano is, okay? So assuming you know those, then you can set up your problem. So I want to go from a meter, and I want to go from a meter to a nanometer. I can set up a one-step equation because I know the relationship between these two units. Now, the question becomes, where do I put the 10 to the negative 9th? And where, like, how do I put it? What do I do?
You would put it at the bottom, but it would be positive.
Okay. What were the steps that we did here? Remember, I asked you what the 10 to the micro was, right? I asked you, micro was 10 to the negative 6, remember?
Right.
And then meter was what? 10 to the 0, which equals to 1, right?
Right.
Then what was the next step?
After that, then we would make the 10 to the negative 6 positive.
No. That wasn't the next specific step, because you have to get the steps right, because then what you're going to do is you're just going to, you know, like, whatever, always change the sign. You don't always have to change the sign. You have to follow the steps, right? So the first step is figure out what the powers are, right? So micro is 10 to the negative 6, meters 10 to the 0, which is 1. The next question that you ask yourself is, which one is smaller?
Okay.
Which one is smaller for micro and meter? It was micro, right? Okay, so if micro is smaller, then I'm gonna need a positive number of those guys to get to one big guy. That's why we changed the sign.
Right.
Because you always go from the viewpoint of the small guy, okay? So try to do those steps and tell me what to put in the second example.
So since the nanometer is smaller than meter, you would have to try to get to like a positive.
How many positives do you need to get to 1 meter from a nanometer?
9.
So where would I put that? Where would I put that 10? You're just telling me it's 10 to the positive 9. So where would I put that? Would I put that next to the nanometer, or would I put that next to the meter?
A nanometer.
Okay, that is correct. And then what do I put next to the meter?
1.
Correct, because you need 1,000,000,000, 10 to the 9th nanometers to get to make 1 meter. Do you understand that?
Yeah.
Okay. Those are the easy type examples. So now you need to, let's go a little bit further. Let's go a little bit more complicated. So these two examples always took you from home base to whatever unit. I want to go now from a base to another base, right? So let's go, I mean, not a base to a unit to another unit. So let's go from kilometer to, I don't know. Let's go to, we just did nano, so let's do nanometer. So again, this is the same thing. It's just that now you're not starting from home base, okay? So remember what I told you, when you write a fraction, you're saying that there's a relationship between those two units. You can do this in two ways. You can do it the fast way, which is sort of the way that we've been doing, or you can do it the long way, which is, by the long way, I mean kilometer. I know that there's always a relationship between the home base, the meter, the guy with no prefix. I know that there's a relationship between the home base and everybody else. So I can go from kilometer to meter and then keep going, because that's not where I want to get to. I want to get to nano.
Meter to
from meter to nanometer. I can do that. That's the long way of doing it. It's not that long. If that's the way, is that the way that you do it? Because if that's the way that you do it, then it's probably easier to just keep doing it like that. When you do it like this, though, it's a little, the conversation that you have with yourself is a little different. Okay, because here I asked you, you did a bunch of stuff. Here, you found out what the power was, and then you asked yourself a question, which one's smaller? And since that one was smaller, you would change the sign to a positive number. So you did a bunch of stuff that you don't have to do if you do it like this.
Right.
But this takes longer. So if you do it this way, which is fine, then all you need to know is memorize. You need to know the powers of 10. That's it. And the powers of 10, the exact power of 10, like you don't change any signs or anything like that. The exact power of 10 goes with the home base, always. So you just need to know the definition of the power. So what is a kilo? The kilo is 10 to the third. Right. So that means that I would put the power with the home base. See, if I did this the other way, the way that I would do, let's just keep going so I don't confuse you anymore. Because that is correct. And then I would do the same thing for the other relationship. What is a nano? The nano is 10 to the negative 9th. We just set it up here, right? 10 to the negative 9th. So I would put 10 to the negative 9th exactly the way it is. Don't change any signs, but I would put it always with the home base is equal to 1 nanometer.
Right.
I guess and this is also correct. You can do it like this. The way that I would do it, since I'm a little bit faster, and I like to teach it this way now because students waste a lot of time doing this, right? They waste a lot of time doing that. But if that's what works, then stick with it. But I would do kilometer directly to nanometer. Why? Because I know the relationship, because I know the power. If I know what a kilo is, which is 10 to the third, and I know what a nano is, which is 10 to the negative 9th, think of a number line. You see what I'm saying? Like from a number line, if you go from how many spots are there from number 3 positive to negative 9? How many spots are there?
It's like 12.
Yeah, it's like 12. Exactly. It's exactly 12, right? So that is the relationship. 10 to the 12 is a relationship between a nano and a kilometer. So now the only thing is, ask yourself that same question. Okay, I want to use a positive exponent. I want to use 10 to the 12. So where do I put that? I always put it with the smaller number. The smaller number here is the nano. So this would be 10 to the 12 is equal to 1 kilometer. One step. Same thing as this, just it takes a little bit less time. But you do have to do a little bit of thinking here. And you have to know, for real, you have to know your powers. All right? One thing I do want to show you is, look at these two. Look at these two. Like, look at this guy here, right? And then look at this guy here, just this fraction. You see how they're almost the same, but they're not?
Yeah.
Like, there's a positive number on the top one. There's a positive number of small guys equals to 1 big guy, right? And then at the bottom, this guy here, there's a negative number of big guys to equal 1 small guy. You see that?
Yeah.
So that's why it doesn't, you can't just memorize one way. You gotta know the powers, and you gotta know how to relate them to each other. Because these two equations, these two fractions, mean exactly the same thing. They get you the exact same answer, all right? Because it's just a different way to go to the supermarket, a different route. Get you to the supermarket, go the other way, not this way. So you have to be able to understand that to do conversions, okay? Does that help?
Yeah, it does. Thank you.
You're welcome. All right. Would you like to do another example, or are you?
I feel like I should like first get to know the chart, and then I'll do more examples, and then as I get the hang of it, I'll email you and get do another example.
That's fine. That's fine.
Okay.
Realize that this, I did say for chapter, okay, so when I said earlier that this is going to be the majority of your exam, I kind of misspoke because I was thinking of a regular semester. Regular semester, the first exam is only chapter 1 and 2, which is the majority would be conversion. Right. You actually, it's not the majority because we have 4 chapters. So my advice to you is that you really, really get this down quickly, because this is not the major portion. You need to have this in the hand, like in the bag, so that you can do the harder things, like stoichiometry and limiting reagents and titration and so on, and naming, nomenclature. There's a lot of other stuff that you need to know, but this is very important because every problem from now on uses this. So if you don't get this, then you can't move on, is my point. Cool. Well, I see that Jawansi is, I hope I'm saying the name right. Hello, how are you?
Hey.
How are you?
Yeah, you said my name. You said my name correctly.
I did. Awesome. So, is there anything that you need help with? You want me to? Anything you need clarification on?
No, not at the moment. I was listening in to everything you were saying about conversions, and I actually know the conversion factors and everything.
You do not know.
No, I do know. I do know the conversion factors.
Okay, so then how about you tell me how to do one? Yeah? What if I give you a problem and you tell me how to set it up? What about that? Just to prove it to me. Put you on the spot.
I could do that, but I'm also driving at the moment too.
You're driving?
Like I'm also
in our class if you're driving. Yes, that is unsafe. So maybe what you should do is not be on, and thank you for coming, but that's unsafe and I don't want you to get in an accident. So this is recorded, you know that, right? So you can watch it. But I do suggest that you guys come so that you can ask questions. The point of these things is so you can ask questions, because obviously, you know, if you're having problems with like simple things, you're going to have a lot harder time with the harder things. So I encourage you to get some questions ready before we meet on Thursdays. Or, you know, if that, whatever, you can always email me, but this would be a good time so I can write it on the board and yada, yada, yada. But please, Jawanzi, please don't crash, please. Anyway, Cecilia, anything else?
I'm trying to think. No, I think that's it.
That's impossible. That's impossible.
Because with chapter 3, chapter 3 is fine because I understand like the nucleus and isotopes and stuff like that. I'm trying to figure out.
So you know how to do percent abundance?
Yes.
You know how to do isotopic abundance?
Isotopic abundance. It's the...
So for example, yeah, because I like to put people on the spot, you know what I mean? Let's, you say you know, prove it to me. So let's do something first, because you said you know isotopes and atoms and all that stuff. So what about, what is this? X is a make-believe, but that's an element. And I'm giving you information about that element. So who is that element?
Okay, so first 20 is the how many is the mass. 10
Okay,
is
what is the
the
mass
protons.
composed of? What is the
No,
mass?
actually no, 20. No, wait, isn't the mass supposed to be on the right side?
I thought you said you knew this.
I do.
FYI. So if you
I
know
know
it,
Isn't the
10.
mass at,
there you go.
isn't the
Jawanzi,
mass
you're
at the
supposed to
bottom?
be driving. I got
No, I heard what y'all was talking about. Like I said, it's a safe driving mode, so all you have to do is just tap it on the speed. I
Okay.
heard what y'all was talking about.
Okay. So tell me what you got.
Oh no, I heard something about on the mass, and I heard isotope, and I was about
Okay. So
to say, isn't the mass on the bottom?
the mass
Or
is,
it,
okay. So since you're not looking at the screen, which I hope you're not, I wrote a symbol. So
oh, okay.
the mass is on the bottom if you look at the periodic table. That is correct. That is correct. But since I'm drawing the symbol, I don't know. Is it the same? Is the mass on
No, the mass is on the top, and
Okay.
the
So what is the mass?
atomic number is the bottom.
Okay, so what is the mass composed of?
10 protons and neutrons.
Okay, so then who is this person?
10 protons is element.
You don't have to guess. You don't have a periodic table. Use your periodic table.
Oh.
Yeah, I don't know these. Okay, so guys, remember what I said in the video? Understand what you're going to be given in the test so you don't have to memorize things, right? So you're going to be given a periodic table. It's just that the periodic table is not going to have the names, right? It's going to have everything else. It's not going to have the names. Like it will have the symbol H, but it's not going to say hydrogen. That's it.
Okay.
So you have
neon.
The what?
Neon.
It is neon. So Jawanzi, just to make sure, you were right, but if you were looking at the periodic table, the mass is at the bottom. But since I wrote the symbol, the symbol has the mass on the top and the atomic number, the proton number on the bottom. Okay, good. So what about then this one? Tell me with this symbol, how many protons, neutrons, and electrons?
There's 26 protons.
How much?
There's 26 protons.
Okay.
No. Yeah, there's 26 protons.
Why?
Because that's the atomic number.
Okay, and where's the atomic number?
On the bottom.
Okay, so this one. Yeah. And then?
There's 20. 8.
Girl, do not try to just
let me use a calculator.
The answer, or use your calculator for the love of Jesus.
Yeah, so there's 28 neutrons.
Okay, so what is that? Neutrons, and how did you get that? For Jawanzi's sake, since he's driving.
Because there's a positive 2 charge. So that means
okay, wait, stop, you're confusing me. You're saying that you said there was 28, that's what you said, right? 28?
No, I'm sorry. There's 26 electrons. And there's 28 protons. No, I'm confusing myself now. I'm sorry.
Yeah. So let's start easy. You said the atomic number is at the bottom, right?
Right.
So atomic number is number of protons. That's 26. Right. Okay. What the right-hand side tells you what? That right-hand number tells you
what? It tells you the charge.
What does that mean? Talk to me like I'm like Barney. What does that mean? The charge. Okay, so the charge is referring to number of what?
The charge is referring to the number of neutrons.
Okay, so listen to the word that you just said, neutron.
But not the number, not the specific number of neutrons, but like.
But Cecilia, listen to the number. Listen to the name of the word. Neutron sounds like neutral.
Oh,
right?
So there's no, yeah.
Right. Neutrons have no charge. So the number on the right tells you the charge, but that means it cannot have to do anything with neutrons because neutrons have no charge.
Right.
So what are the 3 subatomic particles in an atom?
Neutrons, electrons, and protons.
Right. What is the charge of a proton?
Positive.
What's the charge of an electron?
Negative.
Okay. What's the charge of a neutron?
Nothing.
Correct. So back to where we started, 26 is the number of protons. So you got 26 plus guys. Okay.
Right. And there's 20. Oh.
Yeah. Go ahead.
So there's 26 protons.
Okay.
And there's 54 is the atomic mass.
Correct.
So therefore 54 would 54 equals the protons plus neutrons. But since there's a positive charge, a 2 plus positive charge, that means there's less electrons.
So how many are there?
There's
there's no
24.
guessing. Look at the screen.
There's 24.
There you go. Good job. Okay. So to recap, yes, there's 3 things: neutrons, protons, and electrons. Protons are positive, electrons are negative. Neutrons have nothing. The top left number is the mass number, which is, like you said, protons and neutrons, right? The right number is the number of electrons, like you also said. And since it shows a plus charge, that means that there's less number of electrons, because that sometimes is difficult for people, since like it's a backwards calculation. It shows like there's 2 more, but really that just means it's 2 plus, so there's less negatives. So that's why it's a 2 plus charge. So how about this? Because you guys, we have 20 minutes, why not use it, right? So this is the number of neutrons. This is the number of electrons. That's not how I write electrons. I write electrons like that. Electrons. And this is your net charge. Net charge. Okay?
Mm-hmm.
So for example, maybe so you don't understand what net charge is. What is the net charge of this guy that we did before, the iron?
2 plus.
Okay, so there you go. So this guy is the net charge for this particular element. Tell me who this element is. I gave you number of neutrons, and I gave you number of electrons, and I gave you the net charge. So you can somehow figure out how many protons it has, and once you do that, then you can write the symbol. So it has 18 electrons, right?
Right.
What's the net charge?
Oh, it's 21. Sorry, 21.
Again.
the net charge is -3.
Correct, it is, but you said 21. Remember, if it currently has 18.
Oh, I'm sorry, 15 protons, sorry.
Okay.
Negative.
Right.
Yeah.
Simple math, yes? Cool.
Yeah.
All right. So that means it's supposed to have how many electrons? Like
it's 18 electrons.
Yeah, it's supposed to have, without the charge, it's supposed to have how many electrons?
18. Oh, without the charge. Without the charge, it's supposed to have 15.
Right, because this tells you that it's an ion, right? The fact that there's a charge tells you it's an ion. So what I'm asking is, and you already answered it, but what I was asking is, what is the neutral atom? How many electrons does the neutral atom have? The neutral atom has 15.
Right.
So if it's 15 electrons in the neutral atom, then how many protons does the neutral atom have?
18.
Right, so then once you know the protons, then you can tell me who the person is. Who is the person? And I like to refer to elements as people. So who is the person that we're describing here?
We are describing phosphorus.
Is it phosphorus? Yes, it is phosphorus. So to write the symbol, I would write P, and then tell me where I would put the rest of the stuff here.
The net charge would be on the top, on the top right.
Okay. And then
the atomic number of protons would be on the bottom left.
So what's that
15.
number? Okay. And then what goes on the top?
On the top, it would be 16.
What's 15 plus 15?
30, so 31.
There you go. That would go on the top. I love it. Okay, so that's not even isotopic abundance. That's just what I wanted to make sure you understood the things, which you do. You have to practice a little bit more. But isotopic abundance was that in chapter 2? Oh. Let me see if I can find a problem. No, so chapter 2 is more just that stuff, like figuring out who it is, yada, yada, yada. Mass chemical relationships. Okay, so chapter 3, you said you're good with chapter 2, which you kind of are. Chapter 3 is when they start introducing the mole, Avogadro, and conversions between those units, which that is, if conversions between metric units is important, like conversions between stoichiometric units is like super important, like way more important than metric units. So do you understand chapter 3?
With the conversion with these type of units?
Not metric units. Like for example, grams to moles and moles to atoms. Okay. Yeah. So realize, let me put this into perspective. Yeah, I know I've said it, but let me put chapters 1 through 4 are the basis for the entire semester. They really are. So you need to understand how to get them like really well. You need to understand, really thoroughly read chapters 1. Chapter 1, not really, because chapter 1 is more about history. Yes, you need to know that, but you know, it talks about the structure of the atom, which you know, whatever, in Dalton's theory, very important, but it's not actual like meaty calculation stuff. Chapters 2, 3, 4 are the most dense chapters because they have so much information. Like you literally have so much stuff that you have to remember. In a regular semester, I get stressed out with doing chapters 1 through 4 in like 8 weeks. You see what I'm saying? And you guys have to do it in such a small amount of time. So you really, really, really have to concentrate on doing an super amount of problems to make sure that you get it. And the only way you do that is practice. And making sure that you ask yourself, if you keep getting this, like I said at the beginning, if you keep getting the same thing wrong, figure out what that wrong part is and fix it so you can move on. You said that you took advanced AP?
AP, yeah, I took it like, I took it senior year of high school.
Okay, so that's why you're kind of good with this stuff.
Yeah.
But you're not very good with this stuff. That stuff you're not confident in yet.
Yeah, because with the during AP chemistry, we were also given the chart, so I didn't have to memorize it, so I totally forgot everything.
Okay, so metric units, the metric system is way more important than the English system. English system is like a yard, a mile, right? So everywhere in the world uses the metric system. So I require you to know it because I think it's as important as knowing your name. If you're a scientist, you need to know it. You need to know this because most of the basic calculations that we do involve metric units. So that's why I hate memorization. I said that at the beginning. I really do, but this is basic. You need to know this. because that you're going to use throughout the entire semester. But once you know it, I mean, create a little song for it or a rhyme or whatever. Once you know it, then that's it. Because if you know how to set it up, because you said you had the chart before, if you know how to set it up, then you're golden. You just need to memorize the powers, that's all. But then the other portion of that is, like I said, the stoichiometric, like the grams to moles, moles to atoms, atoms back to grams. That is really, really important. So yeah. I guess that's all I have to say. Anything else that you want to talk about? There's so many things I want to ask you to make sure that you know how to do, but I don't want to bombard you. Like, for example, do you have the book?
Yeah, I have yeah, I have the PDF.
Okay, then no, that's going to take you forever to find. But in example, in chapter 3, there's a example like in the chapter. It's example 3.7, so it's the one that goes through all the steps. But anyway, the question asks, it's a very simple question, and it's a paragraph, but basically what it's asking is how many atoms are present in this molecule. That's basically what it's asking. So the full thing says how many hydrogen atoms are present, and then it gives you the amount in 25.6 grams of this molecule, urea. And then it gives you some information that you don't need, which is used as a fertilizer, blah, 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 blah. And that's it. So basically this question is asking, how do you go from atoms to, I mean, sorry, not from atoms. They want to get to atoms. How do you go from grams to atoms? That's basically what this question is asking. So do you know how to do that?
Yeah, by using I forgot what that notation is, the 6.02.
Avogadro.
Oh yeah,
Avogadro is very, very important. But yeah, Avogadro. So if you know how to do that, then maybe just quickly, we're not going to calculate it or anything, but let's quickly set it up so it can make me happy. So it says, just to write it down, it was how many hydrogen atoms, H atoms, are in 25.6 grams of urea, which urea is big, NH2 2CO, right? So, oops.
Right.
And well, they give you another piece of information, but I'm just going to give you that and see if you can tell me how to get the answer. How do I start this? Where do I start?
So first, well, what I would do is I would calculate how many grams that whole of urea, whatever it is, is altogether.
The molar mass.
The molar mass, yeah.
Okay, so they give that to you. The molar mass is 60.06 grams per mole.
Right.
Okay.
So then now that you know what the molar mass of that, you would then start, so you're trying to get from grams per mole, so you would start with 25.6 grams.
I'm just going to put U for urea.
Okay.
Okay, then?
Times. And then you would want, so.
Come on. It's just like this. Look, remember we said how when you set up a dimensional analysis, you got to have the same unit on the bottom.
Right.
So look at the only information you have here.
So you would put 60.06
Where?
grams from on the bottom. No, you would put 60.6 grams on the bottom.
Okay, because this is really 60.06 grams of urea, right?
Yeah.
So that cancels. So 60.06 grams of urea, what goes
over 1 mole? Under 1 mole. Yeah.
Yeah, exactly. 1 mole of urea. But we're not done yet, right?
Right.
Because we need to get to atoms. So what do I do?
1 mole equals, so 1 mole on the bottom.
1 mole, and you have to, okay, with me, I have 2 pet peeves. Okay, you've never had me in class. But my pet peeves are sig figs, significant figures. You have to have that correct. You have to understand significant figures. I'm an analytical chemist, so not doing sig figs correctly can basically screw up my entire experiment in my instrument. Okay, so for me, since I'm biased, it's really important. Number 2, units, complete units. So it's not just 1 mole. It's 1 mole of coffee, 1 mole of pencils, 1 mole of hats, 1 mole of who? 1 mole of urea. Because that way I know that, oh yes, look, it cancels. It's specifically the same thing. So just realize that when you do it on an exam, because I tend to take points off and get upset as I go along. Like, oh my God, 1 mole of what? 1 mole of who? You know, so I'm very big on units, because units, if you know how to set up the problem, then you know how to do the problem. Anyway, 1 mole of urea is equal to, like you had said, 6.022 times 10 to the 23rd, what?
Atoms.
Of squids?
Of urea.
Correct, yes. Because that's what I would think. It would be of squids, if you don't have anything.
Right.
So no, it's not of squids, it is of urea. And that's how you would set it up. Good. That is a basic dimensional analysis problem with stoichiometry. So that is the beginning. I mean, I do have to go because I have another class, but that is the beginning of those. If you can do that, then you shouldn't have any problem. I guess the portion right after, like the section right after, actually talks about percent abundance and actually goes into the isotopic abundance later. So that's what I was originally asking. A lot of students have problems with that one. Right. But good job, Cecilia. And make sure you memorize those metric units and just practice a lot, okay? A lot. And come with problems. Come with a lot of problems next Thursday so we can. Okay?
Thank you.
You're very welcome. Have a good one.
You too. Bye-bye.
All right, see ya.